My name is Dr. Matthias Del Campo. I'm here to present today for convolutions of architecture, problem of interior and exterior conditions in designing with prep convolutional neural networks, which I co-wrote with Dr. Sandra Manninger of the ARIA lab of Spain. So first of all, I would like to give you a certain frame so that you understand what we're trying to do this problem, basically as an introduction. In the design ecology defined by the use of 3D models that allow illuminating the design problem from multiple vantage points simultaneously, such as aesthetics, structure, building method, economy, etc., it seems only logic to introduce these considerations in the work with artificial neural networks. However, the problem of working at the same time on the same 3D model, on the interior and exterior using generative adversarial networks is not a trivial problem. In this paper, we strive to interrogate the abilities of machine vision techniques based on a family of deep neural networks called graph convolutional neural networks to assemble new architectural solutions. This gives rise to an intentional separation of interior and exterior in the design process due to the limited capability of these networks to address both at once. The basis for these processes is a large dataset of architecture divided into two separate learning classes: 3D models, which we collect in the model mine, and plans, which we collect in the common dataset, and this one is in 2D. This specific approach provides the basis for a discussion on the nature of the relationship between interior and exterior. The focus of this paper is on the detailed description of how to create a disciplinary position that copes with designing space in a parallel process of two neural networks models interrogating each other, interior and exterior. Ultimately, this project strives for a dialogue in the mode of design between artificial intelligence and human actor. A methodology that provokes questions about expanding the mind of the designer and aspects of shared agency in a post-human design environment. In the following, I would like to lay out a little bit more about the hypothesis that goes behind the problem that I'm trying to describe here. We have observed in our explorations that we have done in the ARIA lab that there's an either-or problem, meaning that we can use 3D models, but the neural networks will only interrogate the exterior of the model because that's all it understands of the model as so far. I'm not excluding that in the future we might be able to generate neural networks that are able to understand more of the 3D model than just the exterior skin. But currently this is the status quo. And we need to think about what do we do with the interior. In the conventional architecture education, there's a big emphasis into understanding that the interior of a building might also be expressed in the exterior of the project, so that you can read what's going on in the interior through what's expressed in the facade, for example. This has not always been like that. Historically speaking, there has also been a clear separation between exterior silhouette and interior impression of the building. I point out, for example, Christopher Wren's cathedral that made a very specific effort to create an exterior silhouette that would be visible in a specific way, but at the same time had an interior cupola which was formed differently in order to create a very specific interior impression, because the exterior cupola would appear too big in the inside. Just to give you one example. So there has been a separation of exterior and interior before in history. In our case, we're trying to basically turn that into a design methodology, in that we say we can treat with a convolutional neural network, we can explore a data set of buildings that will allow us to come up with new solutions for specific architectural problems. In our case, we reduce the problem to the one-family house in order to create a data set that is consistent and only talks about one-family houses, because creating a 3D data set of all architecture would be a ridiculous endeavor. So you might ask, well, there is already data sets out there that are 3D and that you could use for architecture. Yes, it's true, there are data sets out there, for example, ModelNet and MeshNet, that include houses. However, the problem we encountered is that because those houses are neither modeled by architects nor labeled by architects, or not in our cases, we run into the problem that there is not a really inherent expertise present in those data sets, which led us to the decision to create our own data set. This is a global effort. We also try to make these data sets as inclusive as possible, because current data sets have bias that lead towards Western architecture. So we try to overcome that by including as many architects from everywhere in the world as possible in the modeling of the models, but also in the labeling of the models. So this brings us to a larger problem with working with AI in architecture in general, which is the lack of data sets that allow us to interrogate architecture with more information. As I mentioned before, we divided the problem into two specific things, the exterior and the interior, and they are developed more or less independently from each other. However, in the further process in this hypothesis, we're seeking to create a workflow that combines both of these neural networks into one workflow, to avoid separating those into specific compartmentalized problems. It also comes along with the question about sensing and perceiving place in the age of quasi-intelligent machines. It's a very interesting problem, which leads us to the idea of post-human perception of the world, in that we as actors are not anymore solely responsible for observing the planet or observing the world. Machines are also seeing the world now. Machine vision has shown us that machines perceive the world differently. They also use different methods than humans to perceive the world. I just will point out LiDAR in this as an example, but it opens up the possibility to understand that the plateau of observation of the world has been starting to be shared with another actor, which I think is a very interesting problem to have. Let me talk a little bit about the results that we have had so far with our attempts to use convolutional neural networks for architecture design. In the last year, I 3D modeled a data set of 1,500 columns and houses. We tried to work with the houses data set first. The idea behind this dataset was a very objective one, which is, can a convolutional neural network replicate my sensibility as a designer? And for that, it was necessary that I, as Matthias del Campo, sit down and 3D model these models manually on my own and also label them alone to be sure that the sensibility is really captured from my side, right? So if anyone asks me what I've been doing during the COVID pandemic in the summer of 2020, I was just labeling a data set. But it was useful because at the end of the day, by fall, we were able to create the first results out of the data set. And what it does basically is convolutional neural network is it takes a specific geometrical figure, like a sphere, that is subdivided in a specific amount of faces and edges and points. And then based on the data set of houses that are modeled, it will start to strive to replicate that information that it can extract from the data set about specific features that I include in my models, obviously, even unconsciously. And it was an interesting result in that the resulting house was actually usable. So we could basically go ahead and 3D model this completely and add more detail and so on to it. So this being said, the process still is very rudimentary and it will need far more work to get to a level where this becomes really usable on a day-to-day basis as an architecture design method. But as Alberto already said, nothing new is perfect. So it just needs time to get to the point, which means bigger data sets, which means better labeling. And to move from that experiment, which was designed to capture my own sensibility, we're trying to get to something that can be objectified more generally, which is a data set called ModelMind that we're working on at the moment, which includes several people around the world, again, modeling those models to get to a data set that is big enough that we can use it with neural networks. I'm talking here starting 1,500 models upwards. 1,500 would be the absolute minimum. The goal is rather to go to something that is more about 10,000 models. So these are the results we've got so far, the results from last year's dataset building and modeling. As a conclusion, I would like to say that there's still a lot of space to be explored here. In particular, again, to go back to the original questions of this paper, which is the relationship between interior and exterior, specifically using neural networks. There's still a lot that has to be done. In our opinion, we need to combine several neural network techniques with each other, concatenate them, in order to be able to solve this problem with one technique instead of dividing this into several patches and pieces. The challenge in that is that the calculation power necessary to run those concatenated neural networks might be quite challenging at the moment. The lab, ARI lab, is in the happy situation to have received some funding that allows it to run models for longer time on GPUs, and we hope that by the end of fall we will be able to start implementing the currently being built datasets, Common House and Model Mine, in a larger role, so that we can really use that as a design method. And most importantly, both datasets are going to be publicly available. So this is research that we're doing for the architecture community, so that architects in the coming years can use these datasets in their experiments, searching for methods to apply AI ideas and AI methods and neural networks in general to their design ecologies, whether it's their offices or whether it's students experimenting with these datasets. With this being said, this would be the conclusion of our paper. I'm looking forward to hopefully present in the future the results of this year of the dataset building, and also the results of what it will produce architecturally speaking. It's a design environment that I'm highly fascinated with, as it is basically producing architecture when you're not doing perfect curve fitting, though, I have to say that. It's producing architecture that is highly provocative in that it is strange but familiar enough. And this moment of strangeness but still familiarity is what makes it very acceptable for people to consider that it is part of our larger trajectory of architectural history and the history of a discipline. But at the same time, it's not imitating something. It's not being historicist in any way. It's basically learning features from whatever data it's fed, but instead of copying whatever it's seeing, it's producing something that is really an interesting provocation for the discipline in terms of how the role of the architect of the future will be. Is our role as architects in the future the one we have known so far, which is to sit down, take a piece of paper and sketch a plan? Or is it rather going to be a trainer? Are we going to become trainers of datasets, trainers of neural networks that allows us to interrogate large chunks of the architecture we've produced in the thousands of past years to hopefully produce something exciting, new, and exciting in the future? So I'm very much looking forward to that. And in the meantime, I say thank you very much for giving me the opportunity to present to you today our paper, Convolutions of Architecture, and I hope that it will provoke one or the other question. Thank you very much.